First, let's talk about the Big Bang theory. After the Big Bang, the universe was almost entirely made up of the elements of hydrogen and helium. In the process of carrying out nuclear fusion to power themselves, the hot cores of stars served as laboratories to fuse lighter elements into heavier elements such as oxygen and iron.
When massive stars die, they explode. This explosion, known as the supernova, releases the heavy elements from the stellar core, at the same time producing even heavier elements owing to the extreme condition of the explosion.
This explosion pollutes or enriches the gas in the galaxy. Therefore, when subsequent generations of stars form from the debris of dead ones, they carry the fingerprint of the previous explosions.
Now, we would like to talk about the formation of galaxies. Galaxies were born when the vast clouds of gas and dust collapsed under their own gravitational pull, allowing stars to form.
The other, which has gained strength in recent years, says the young universe contained many small lumps of matter, which clump together to form galaxies.
The first stars did not appear until perhaps 100 million years after the Big Bang, and nearly a billion years passed before galaxies proliferated across the cosmos. All galaxies are embedded in big spheres of dark matter, also known as the dark matter halo. This substance does not emit electromagnetic radiation, such as light, infrared, etc., nor they interact with the normal matter that we see, stars and galaxies, in any way except through gravity.
Next, in the creation of the universe is the sun's birth. The sun is about 93 million miles, 150 million kilometers from Earth. Our sun is in a spiral arm called the Orion spur that extends outward from the Sagittarius arm.
From there, the Sun orbits the center of the Milky Way galaxy, bringing the planets, asteroids, comets, and other objects along with it. Its spin has an axial tilt of 7.25 degrees with respect to the plane of the planet's orbits. The Sun and the rest of the solar system form from a giant rotating cloud of gas and dust called a solar nebula about 4.5 billion years ago.
As the nebula collapsed because of its overwhelming gravity, it spun faster and flattened into a disk. Most of the material was pulled toward the center to form our Sun, which accounts for 99.8% of the mass of the entire solar system.
Last but not least, let's talk about the formation of Earth, planets, and Moon, due to the explosion of a nearby star called a supernova. This explosion caused ripples in space, which caused the cloud of gas and dust to contract. This contraction caused the cloud to begin to collapse as gravity caused the gas and dust to attract each other, giving rise to a solar nebula. The cloud began to spin as it collapsed.
Eventually, the cloud got hotter and thicker in the center, with a ring of gas and dust enveloping it, its center being hotter and its ends cooler. As this ring became thinner and thinner, the particles began to stick together and form clumps. Some of these clumps got larger as particles from smaller clumps were attached to them, eventually forming planets or moons.
Like the other planets, Earth formed from the leftover cloud of dust and gas orbiting the young Sun. The early solar system was a violent place, and a number of bodies were created that never made it to full planetary status.
One of these could have crashed into Earth not long after the young planet was created. The prevailing theory supported by the scientific community, the giant impact hypothesis suggests that the Moon was formed when an object smashed into early Earth. Known as Theia, the Mars-sized body collided with Earth, throwing vaporized chunks of the young planet's crust into space.
Gravity bound the ejected particles together, creating a moon that is the largest in the solar system in relation to its host planet. This sort of information explains why the moon is made up predominantly of lighter elements, making it less dense than Earth. The material that formed it came from the crust, while leaving the planet's rocky core untouched.
As the materials drew together around what was left of Thea's core, it would have centered near Earth's ecliptic plane, the path the sun travels through the sky, which is where the moon orbits today.